Hello everyone, welcome to Java Tutorials. My name is Kishore. In this video, we will discuss how to maintain complex types of data in a list. To add the elements in the list, we first need to create the complex type. For that, I will create one new class here with the name called product, and let me keep it in one package called com.examples.collection. That is where I have this main class also. And in the product class, we will create some properties because I'm going to add this object to the list means I need to also have some properties like product name, product price, then product ratings, product ID also. I will create ID, then name, then price, and lastly rating. I will generate constructor using fields, and I will also generate a default constructor. Then I will create one more, that is a toString method, so that if you print the product object, it should not return the toString of object class. I want the product object properties should be displayed. Then we will also generate setters and getters. This is just to access some of the properties if I want to modify or if I want to read. So we are done with creating the properties. Then we will use this constructor to pass ID, name, price, and ratings. Anyway, it is of no use to use default constructor. I just created simply. 1 minute. What happened? Yeah, data setters are there. Let's go and create the list object first. I will import from the util package, and I write here product type. Let me use product and new array list. And then let us add some products like this. I will directly add new product. I can do like this, and I need to pass the ID. Let me pass the ID 5, then laptop, and price something like 50,000.0, and then ratings 4.5. Let's copy this line, and 4 5 products we will add. We will add 7, and this is TV, and 75,000, then 4.3, then mobile, change the product to some number, then 35,000, then 4.2. This is product number 4, laptop, then 70,000, 4.8. This is going to be product 2, TV, then 80,000, 4.9, 3, and this is going to be mobile, 40,000, 4.6. We have added few products, and we will see the total elements by using the size. List.size will give me the total elements present in the collection. So it is 6. And if I print the entire list, this is what the output I get. I see all the product objects getting printed because the toString is overridden. What we will do, each element we will iterate by using the iterator. So we have used the iterator on the normal simple type as well, correct? Now this time I need to use iterator like this. So we know what is the way to create the iterator type. So first let me create the iterator, and list dot iterator is the method we need to call, and then we need to use that as next method. If in case I want to remove the element, I can use that remove method also. I will use it dot as next, and then what I will do is I will call the next method, but this time the next method is going to return product object. So you can use this p variable of product type and call the next method, to get the product object, and you can print the product which is iterated. And now if I run the program, I should see every product object getting printed. Now I want to remove the product whose name is or rating is greater than maybe 4.5 or less than 4.5, whichever the product that has the rating less than 4.5 I want to remove. Then what I will do, I will write if p dot get ratings is the method that returns each product object ratings, and then I will write less than 4.5 I need to remove. So I will write p dot, not p, it dot remove. I will not print, because if it prints every iterated element, even the removed element also it will print, because here we are assigning the iterated element to p, and even after removing also it will print. What I will do, I will use another iterator, or I need to reiterate by using list dot iterator and assign to the it, so that after remove what happens we'll see. So after remove I need to print. I will just copy this and run here, paste here, sorry. And if I run the program, after remove, oh, less than 4.5, everything is removed. Just a minute, what happened? I didn't print, I think. I removed again. That was the problem. Let me print. Yeah. Now it is going to print the products which are having greater than equal to 4.5. See, there are some products which were less than 4.5, like which one? For TV of price 75,000 is not there. See, but you can see mobile whose price is 35,000 is also not there. To clearly understand that, I can print it here before the remove. Yeah, we will do that. What I will do, I will just print here. So before remove, each product we will print, and this time I can see before remove we have this much element, and after remove it has removed all the elements which are less than 4.5. See, 4.2 is removed, 4.3 is removed. So that way that iterator will be very much useful. But now you cannot use the list dot remove method. If you want to remove a particular element, how do you remove it? So you need to create a product object of this property, and remove means how it is going to work. That is going to be not possible, correct? You should have the same reference to remove, correct? So for example, if I have here something called a single object of product in a variable called px, and let me say this product object, and if I try to write list dot remove, will it work? Let's see. If I run the program, it's not working, because none of the product object it is going to remove, and we will keep this product itself, which is actually 4.6. We'll use this product object which is actually having the rating 4.6, and it is a mobile. And if I remove this, will it really remove this? Let's see. If I run the program, see, it is still not removed. 40,000 is still there, that ID3. The reason is, when you added this product object, its memory address is different, and this is having a different memory address. And based on that reference only, it will remove. If in case you have created each product object with some reference, and if you had passed that same reference, it would have definitely removed. That's how this remove method of collection works. It is going to remove based on that reference. And similarly, you can use the index to remove. That is going to work. If I say remove of, say for example, this is the one I want to remove. Now what is the index number of the last element? Because there is 1, 2, 3, 4, 5, 6, I can write 5. But this time what happens, I will comment out this. This time it is going to remove based on the index. So it will be definitely removed. You can see there is no element which is having the product 3, mobile and 40,000. Even before remove also, after remove also it is not there, because before remove only we invoked the remove based on index. This is one thing. Let me comment out this. I want to show one more thing. In the list there is something called get method, which is going to give you the element based on the index. Suppose you want to get the element based on index, that is also possible. Like this, you can directly print like this, product equals list dot get the very first element if you want to get. What is the very first element? The product which has the ID 5, right? You can get that also. Where is that? Product equals where I am printing before the size. Yeah, this one. So this way you can actually use complex type, and how you would iterate and how do you remove. Then what if I want to sort these products? Instead of iterating, I want to sort it. Is it possible to sort? Yes, it is possible. What Java provides is, whenever you are using the list, whether it is an array list or linked list, to sort, they have provided one class called collections class. So this collections class you can use to sort. Now, what is this collections class? Is it similar to the collection interface? Actually, no. If I use Control Shift and type collection, look at the names here. It is an interface. Collection is an interface, and the collections is a class. We need to use this class, collections class. So this collections is mainly used to perform some extra operations on the list, where you want to sort or you want to shuffle the elements, you want to search the element. You can always do that with the collections. How do I do this? Let me show you. Let me first take one simple type. We already have that in our previous program. We created one simple type, correct? Test list. I will take this number and I will remove all these things. Let us simply keep this much. The reason I am showing in simple type first is, with complex type, I need to show some extra implementations for that reason. Now this is how the list is looking. If I print the list and run the program, I see 2, 3, 4, 5, 10, 60. It is already sorted. Let us change this. I will make this one as 9, this one 4, sorry, this one as 9, right? And this one 2, this one 8, this one 5, and this one is 1. This time you can see the insertion order, and anyways it is not in sorted order, neither in descending order nor in ascending order. What you can do, you can use the collections class that has some methods like sort method is there, shuffle method is there. So you can use this one. So let me use the collections dot sort method. You can see there are two sort methods. One takes the list and another takes the list comma comparator. We can use the second parameter sort later. First we will use the collections dot sort. We need to pass the list. So this is the list. And after sorting, what is the output? We'll see. If I print the same list and if I run the program, you will see that is sorted. But you observed there was one particular sort again, but it was taking two parameters. What was that? Actually, the second parameter was, if you observe the collections, and if I go to the sort method, see sort, one takes the list comma comparator, and another one, where is that another one? That is taking, let me search here, sort, this is the another one. Look at this, there is a sort method that, not this one. Mm, sort method. Um, okay, I think the same sort method, correct? Which is taking somewhere the sort taking list should be there. It's not still searched. Okay, I will write sort comma list. It is not there. I am searching in list. I need to search in collections. Okay. Sort method which is taking list and comparator and one more where is that? Yeah, this is the sort method I was talking about. So this sort method taking the list you can observe and it is taking a list and another one you observed it was taking two parameters, correct? That is list comma comparator. So what is this comparator? Comparator is one of the interface. It has one method called compare to method. It is a functional interface. It has only one abstract method that is called as compare method. That is the only abstract method present in comparator. So you can use this comparator whenever you want to customize your sorting. Now, as per our output, we are sorting. So by default, all the simple types are sorted in ascending order. Okay, but what if I want to sort in descending order? Then I should implement comparator interface and I need to pass that as a parameter. But comparator interface as compared to method. There are three different ways to implement comparator. One is you can implement like this class sort implements comparator where you need to pass you are comparing what you are comparing integer because you want to sort the integer values and you need to implement a compare method and look at the compare method. It takes two integers and compare. So what are those two integers? Those are going to be these values only. First, what I will do is, I will just tell you what is this compare method going to do. This compare method will just compare two integers and returns some integer value to the sort method. And we will change this name to sort in DSC. So which sort method? This is the sort method. To that sort method, the compare method returns some integer value, which can be negative or zero or positive. So based on the negative, zero or positive, sort method is going to arrange the element. So let me write like this. Integer dot compare by passing O1 comma O2. Now you might be thinking, what is this integer dot compare going to do? The integer dot compare, what it will do is, whatever the two parameters the compare method takes, I am passing to the compare method. So compare method is going to compare these two values and it is going to return some integer value which can be negative value or zero or positive. Means internally the compare method is going to do this O1 minus O2. If O1 is 5 or and O2 is 6. What happens? When you pass 5 comma 6, the integer dot compare 5 comma 6 is going to return 5 minus 6, which is going to be negative. Similarly, if the O1 value is 6 and O2 value is also 6, then the integer dot compare is going to give 0. If O1 is 6 and O2 is 5, in that case, O1 minus O2, that is going to be positive value. That is what integer dot compare is going to do. So this positive and negative value is very much important to arrange the numbers O1 and O2, whether it is negative or positive. Based on that it will arrange. Now how it will arrange, I will tell you. Now assume that O1 is 5 and O2 is 6. In that case, what integer that compare will do is it is going to just compare by subtracting 5 minus 6, and what it gave, negative value. Now if it is negative, what it will do, it is going to understand, okay, it is actually giving negative value. If it is negative, then it has to keep towards left side. If it is positive, it has to keep the element towards right side. If it is 0, it has to consider that as a pivot element. But now what is that pivot element means? Before comparing, what happens is, when compare method takes two different values, before that it is going to take the same value, means the sort method is going to take all these elements, but before that the O1 value and O2 value will be same. First it is going to get that pivot value, that is 5 minus 5, which is going to give 0. That is the pivot element. Then it is going to take the next element, maybe O1 value is going to be 6. And what about O2? O2 value will be 5, which is already sorted. Now what happens? 6 minus 5 is going to give positive value. So now what happens? According to this 5, which was already sorted, which is a pivot element, it has to go towards right side of that 5. The 6 will go towards right side. Means first element it compares is the same element, that is 5 and 5. So 5 is the pivot element. Next O1 is 6 and O2 is going to be the already sorted element, that is 5, and 6 minus 5 is going to give me positive value. So that 6 should come towards the right side of the pivot element, that is here. Next, let's say O1 is 8, then what will be the O2? O2 will be 5 and 6 both. First it will compare with the pivot element 5. 8 minus 5, it is going to give again positive. It means it should come towards the right side of 5. But there is another element already. If it goes towards the right side of 5, it has to still check with the 6 whether it should be before 6 or after 6. So again what happens, for the same element 8, the already sorted element 6 is also will be supplied. So it is going to be 8 minus 6, which is going to give positive value again. So it means 8 should go towards the right side of 6. So 8 will go here. And let's say now already three elements are sorted. Now what about now if O1 is 9 and O2 is going to be what? It can be 5 or 6 or 8. First it is going to be 5. Next it will be 6. Next it will be 8 if it goes towards the right side. So obviously 9 minus 5 also gives me positive. So it will go towards the right side. Then again 6 minus 5, it will go towards the right side. 8 minus 5, again it will go towards the right side, and it will be 9. Let us take some lesser value like 3. In that case what happens? Then O1 will be 3, O2 will be the pivot element 5. So it is going to be 3 minus 5. But this time it won't give positive, it will give negative value. And we need to understand here, if it is negative, it should go towards the left side of the pivot element, that is 5. Left side means this one. So 3 will come towards the left side. This way, the sort method is going to arrange the elements based on the compare method return type. So this O1 and O2 are the parameters. Now if I pass the object of this sort in descending order as the second parameter, because the collections dot sort takes two parameters, one is the list and another is comparator object. So we need to pass the object of this class, and when I pass the object of this class, that is going to be like this, new sort in DESC. What happens is we are actually going to get the value based on the compare method return type. The list is having 942851. So now let's see what happens. So O1 value will be 9, O2 value will be 9. So it is going to be 0. So 9 is the pivot element now, because 9 minus 9 is 0. Next is 4 is what going to be compared with 9. Now what happens? O1 will be 4 and O2 is going to be 9. So which leads to 4 minus 9, that is going to be the negative value. Negative value means it should come towards the left side of the pivot element. So 4 comes here. Next is 2. So 2 is the value of O1, that is the first parameter, and O2 is going to be the already sorted element. First is 9, next it is going to be 4. So when it passes 9, what happens is 2 minus 9, which gives the negative value, but already one more element is there. So it is going to again use this same 2, and O2 value will be the another sorted element. Then 2 minus 4 will again give negative. It should go towards the left side of 4, then 2 appears here. So here it is going to sort in ascending order. That is what already sort is doing. We need to interchange this parameter so that we will be getting positive when it was returning negative, and we get negative when it was returning positive, correct? So we will just interchange the parameter. Then what happens is it is going to be, now instead of 2 minus 4, it will compare 4 minus 2. In that case 4 minus 2 will become positive, so that 2 will go towards the right side of 4. If 2 goes towards the right side of 4, what is the meaning? Then it is actually sorting in descending order. Anyway, if 9 is not already 9 will be sorted, means 9 will go like this, correct? And in case next one, let's take 8. So O1 is going to be 8, O2 is going to be 4. So 8 minus 4 will give positive. It should go towards the left side of 4, means here. And again 9 is there. What it is going to do, it is going to again pass 9 and check, okay, 8 minus 9. 8 minus 9 will give negative value. It should go towards the right side. So this way, right side of 9. So this way it is going to sort in descending order. And the compare method is just telling the sort, this is what the value you get when two numbers are compared, whether positive, negative or 0. Based on that, it has to compare. Now if I pass the object of sort in descending order, look at the compare method in the of integer dot compare method. What it is doing is it is interchanging the parameter. So it will give some positive or negative or 0, and based on that it is in descending order. That is how the sort method works. But I told already that there are three different ways you can implement. This is one way. But the second way, let me comment, this is not going to be that much like user friendly, because we need to create multiple sorts, means we need to keep on creating multiple classes, correct? Suppose we want to sort the complex objects, means then we would be creating multiple sort classes, right? Like I want to sort based on price, but in ascending order and descending order. I want to sort the product based on name, means ascending order, and descending order means too many classes I would be creating just for sorting. That's why what Java recommends is you use anonymous implementation. So how to create anonymous inner class? Let me show you without creating the separate class. You know that you can't create the object of interface, but you can always create an object of anonymous inner class. So you can write comparator, but like this, where you would be writing the compare to method, that is compare method implementation inside this particular anonymous implementation. Like this, you can implement the compare method, and you can use this reference and pass to the, where is that sort method? I had to write that sort method. Means instead of writing collections dot sort and passing list comma that new object of comparator, I can pass this C, where C is going to be the anonymous implementation of new comparator, so that whenever you have multiple sorting technique for a complex object, like 5 6 properties are there, and all those 5 6 properties, based on that those 5 6 properties you want to sort only in ascending and descending order, means 6 5 means 5 into 2 10, 10 different sorting technique you need to write, means you cannot write 10 classes, it will be too much of files you would be creating, too much of classes you are creating. What you can do is inside the method itself, wherever you want to sort, before that you create an anonymous implementation and you pass that reference. So you create 10 reference. That will be much simpler. That is how the developers also do. Now we will create the anonymous implementation for this, and I will write comparator, and it has to compare integer. C equals new comparator, and anonymous inner type automatically Eclipse will give you to use that. And look at this, already it is terminating that anonymous implementation, and you get an error because this is like an anonymous class. When you implement an interface, you have to implement the method present in that interface. You just place cursor over it and select add unimplemented methods, so that you get the compare method. And this time what you do, you write integer dot compare o2 comma o1. It is just similar to how I wrote this class, but I am not writing a separate class. I am writing the anonymous implementation of comparator. Now we will pass that C to the second parameter. We are going to get the same output. See, we are still getting the same output. Next is, this is the second implementation where you are going to pass anonymous inner type. But I will show you another new way which is much more simpler. That is called as lambda expression. Now, what are these lambda expression means? Lambda expression are simple expressions that can give the implementation to the interfaces which has only one abstract method. So the interfaces which are having only one abstract method can always use the lambda expression, and those interfaces are also called as functional interface. The reason is we are going to just pass function as a parameter instead of the object as a parameter. Here what we are passing object as a parameter. But what we can do is we can also pass lambda expression here. And how do you write a lambda expression is, see, this is going to, I can reduce this. Let me copy this entire thing, and I will write here instead of C, I will write C2. Lambda expression is going to reduce all the unnecessary things in anonymous class. Because the comparator has only one abstract method, you don't have to write all these things. Means you can remove this complete body of the class and closing of the class. That is one thing. You can remove this override annotation. You can remove even the compare method, the return types, the signature, public keyword, everything you can remove. Then you can just write one arrow mark and the body of the compare method. And it is exactly going to be treated as the implementation of compare method. The comparator is the reference variable. This is the logic of compare method, which is returning integer.compare, and opening and closing flower bracket is not necessary if it is only one line statement. And if it is only one line statement, even return is also not necessary. Let me remove this comment. So you can remove these flower brackets and even return statements also. So it is going to become just the return statement is integer.compare for this compare method. And one more thing what you can do is you can also remove the parameters type. So this is the implementation of compare method. How does Java compiler know it is an implementation of comparator? It is going to understand based on the variable type, and it understands when you are using lambda expression, you are implementing the compare method that is taking two parameters, and it returns integer.compare of these two parameters. And you can directly pass this expression to the sort method, or whoever is taking comparator as a parameter, they all can take the lambda expression itself. This lambda expression is just a function. That's why it is called as functional interface, where it allows you to pass functions as a parameter to the references. So will it work if I pass this lambda expression? Yes, it will work. See, I can write C2 also, it will work. First, let me write C2. And if I pass C2, I am going to get the same output. Look at this. But if I interchange this O1, O2 to O1 and O1 to O2, it has to understand that C2 compare method is implemented this way, means in ascending order. And the comparator is telling that it has to be sorted in ascending order. In ascending order also it's coming. But we know that even if you do not pass comparator, by default the sort with only one parameter compares and sorts in ascending order. But I am just showing that. And let us keep O2 comma O1 and again run the program. This time it is going to sort in descending order. And I can also pass directly the lambda expression. So because earlier I passed C as a reference, by implementing this big implementation of comparator, I can now pass compare method logic. You need to understand comparator as a compare method with the two parameter, that is O1 comma O2. Then what it has to return? It has to return integer dot compare O2 comma O1. Now what happens? It is going to use this lambda expression, and whatever compare method returns, based on that the list is going to be sorted, that will be in descending order. So these are the three ways, and you can completely ignore using the class based implementation of comparator, which is not required, correct? And we also can ignore implementing through anonymous type. We can simply use the lambda expression, and you should use only for functional interfaces. This is a simple program how we sort the numbers, but we need to use different objects like product objects, customer objects, employee objects, where we can pass different types of comparators, where we are going to sort based on salary, if it is employee, ascending and descending. If it is a price, both in ascending and descending, we can sort. So let us discuss that one. So what we will do is, we will make use of this list complex object, which we actually used, correct? Let us run this program, and we are getting this output. What I will do, I will simply remove everything, whatever is there. And let us simply print here with one void print elements. If it takes a list of product and it is going to be products, what I am going to do is, I am going to just use a for loop to print the product object, so that it will be easier for me to call this print elements, and I will print that product. So I don't have to every time use the iterator, correct? Or I don't have to use every time the for loop. So I will call the print elements and pass the list, and let me have one delimiter after printing. So this is going to print the product object, correct? Now let us try to use the comparator now, but completely with lambda expression. And remember, now this time the comparator type should be product, not integer. Earlier we used integer because it was comparing numbers, but this time it is product. How it is going to compare? We need to understand it is going to be like this: C equals to integer, instead of integer it is going to be product P comma product P1 comma product P2, and there it has to return P1 dot get price, P2 dot get price, like that. So let us try to sort based on the price. First we will sort based on the price. It is double. Even in double also we have a compare method. Just like integer dot compare, even double also has a compare method. Let me show you using Control Shift T, double class. And if I use Control F and call and search for compare, look at the compare methods. I think I've opened a wrong one. Double. double from lang package. Okay. Now, if I search for compare method, compare, let me search. Look at this. See what compare method is doing? It is, yes, this is the compare method I was talking about. So it is taking two doubles and returns the integer. So we just need to call the compare method through the class name because it is static. Let's do that for the product object. So this time what I will do, I will use the product P1 comma P2, but this time I have to use like this double dot compare. I cannot directly pass P1 comma P2, correct? Because P1 is a product object. P2 also product object. We should say P1 dot get price and P2 dot get price, so that two double values will be compared. So what I will do, I will use collections dot sort by passing list comma P1 comma P2. That is enough. And just write P1 dot get price, that is double dot compare P1 dot get price and P2 dot get price. So instead of creating a reference and creating like this P1 comma P2, instead of creating a reference and creating the lambda expression with just like this, I directly passed this particular expression. Now, how does comparator knows that it is how does this know that it should be on product? Because the particular list is actually having product. It is understood. Now, these two parameters are of product. The comparator should be of product type based on this list. But if you pass a list which is of number, then it will give an error. Now what happens is it is going to sort based on the price in ascending order. And after that, if I print the element, what happens? Let's see. So before sorting the price, look at the price 50,000, 75,000, 35,000. They are not in order. But after sorting, look at this 35, 40, then 50, then 70,000, 75 and 80,000. Next, we can write one more sort. Let me write another sort. This is sort based on the ratings, and I will just paste this same lambda expression, but this time what I will do is I will compare get price with another product price. And if I run this program, let me first print. So this is going to sort based on the ratings, correct? And if I run the program, it should sort based on the ratings. Uh, Look, what did I do? Oh, I made a mistake. Sorry, sorry. Get ratings. Get ratings, and here get ratings. Now, based on the ratings, it has to sort. So 4.2, 4.3, then 4.5, 6, 8, and 9. So what we understood is you can sort the list, and you have various type of sorting you can do. It could be in ascending or descending, and various type of properties you can sort. Now you can actually assume if the customer chooses some checkbox filter ratings ascending and descending order, this statement is executed. And look at the lambda expression, which is much more simpler compared to writing the anonymous inner implementation or a separate class, because the product has totally four properties. If I want every property to be sorted both in ascending and descending, I would be writing 8 classes, or I would be writing 8 anonymous implementations. But if I have a lambda expression, at the time of calling sort only I can pass the lambda expression and I can sort. Lambda expression is going to take some time for you to understand. Just practice few times and just look at the way I implemented anonymous implementation, and I reduced that to anonymous. I reduced it into lambda expression. Just look into that so that you can get comfortable. So that is how you do sorting for complex types, and also how you maintain the complex types. So see you in the next video. Thank you so much.